Hello community, let's talk about transformer-based language model. And we are at the current state of affairs. We look at the T5X model and of course the Palm model by Google. And we look at the last video where I showed you that BERT and GPT are more or less the encoder stack of the transformer architecture. This is BERT, and the decoder stack of the transformer architecture, which became GPT by OpenAI. Now, GPT as being just unidirectional, we found out that we can use the decoder stack of the transformer as a language model. So a model trained purely for the task of next step word prediction. Great. BERT, on the other hand, is bidirectional. It is an encoder-only stack, and it is great at doing the single prediction per input token. So great for classification tasks. Currently, if you ask, we have T5. And this is a multitask unified model, or short MUM. And this is the technology that powers Google search today, if you believe current research publication. Of course, to be specific, since the mid of 2022, you have T5X. You have the text-to-text transformer in JAX and in FLAX. So utilizing the compute infrastructure by Google. And if you want to know more about JAX, I have a video about JAX in TensorFlow and Pytorch. And if you want to know about the hardware configuration of H100 GPUs by NVIDIA or the ASICs by Google, I have also a video for this. Now, in July 2020, we had the publication by Google about its T5 architecture and their ideas behind this in a preprint publication. They focused specifically on transfer learning in natural language processing, and they say we often have this pre-training part on unsupervised learning and unlabeled data, that we have so much data free from the internet. And they examined this transfer learning model when they had first a pre-training on a data-rich task, before then fine-tuning the system on a downstream task. Now, actual downstream tasks are question answering, document summarization, sentiment classification, and their idea was to put everything in a text-to-text framework. And they wanted to explore the limits of transfer learning. And of course, they used a transformer architecture. This means more or less that they used on the encoder stack also something like BERT's MLM modeling. They had a dropout of 15% of the token in the input sequence, and they even cared about to reduce the computational cost of pre-training the model. But the great thing about Google is they open sourced it. You have here the GitHub directory by Google Research, where they provide you the code, and as you see, it has been updated just 2 weeks ago. And they even provide you here with a free Google Collab notebook where you can experience T5 yourself. Of course, not the full-fledged half trillion parameter model, but the smaller model that fit within the Google Collab notebook. And here we are now here in our Collab notebook from Google about T5. And as you can see, it is about fine-tuning text-to-text transformers for closed book question answering. And you have here all the code. You see how you set it up on a TPU is some easy pathways. Then you have natural questions. You have the code to code this in detail. If you want, I can make a video going with you step by step through the code, but it is really easy to implement. You have to transfer to new task. They explain in detail to you how it is done, how it is coded. A very nice implementation, expected results, how you evaluate your model, of course, and they give you all this code to play around. And then, of course, most important, the predict functionality of the model. And you have here your question that you can define, and you see the output here now on the T5 model. Of course, since you're working here on a free Google Colab notebook, you cannot use the highest and this half trillion parameter model, but also the smaller T5 implementations show you what you can achieve with the current and open source T5 code. It is free for you to explore here on a free Google Colab notebook. So summarizing, we can say T5X combines the pre-training and the fine-tuning for specific tasks. It is pre-trained on multitask mixture before fine-tuning for specific task. And Google itself claims it is 1000 times more powerful than BERT. I can verify this, but we have a question now. What about the future of this? And especially if you think about conversational AI tools like ChatGPT. Now, the answer is easy. But before I give you the answer in my next video, I want to show you that T5 also evolved in FLAN T5. I have 2 videos for you where I show you the code and the tuning of the hyperparameters. I hope you enjoyed this, and I see you in my next video.